Okay, welcome to video 10.7. Today we're going to be continuing our conversation on the quadratic formula. So, as you know, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a, which is found on their formula sheet. So all you really have to do to solve these quadratic equations is to substitute in a, b, and c in place of a, b, and c in the formula. But in order to do that, as with any time we solve for the roots, zeros, or x-intercepts, we need to make sure that our equations are in standard form so that they're equal to 0. In this example, it's negative 3x squared. So I'm actually going to add that to the other side because then I'll have a positive x value, which is good, and it'll all be equal to 0. Okay, so once I do that, I get 0 equals 3x squared plus 8x minus 12, and then I have it in standard form. So off to the side, I wrote down that a equals 3, b equals 8, and c equals negative 12. I got that all from the standard form of a quadratic equation. And then I can go ahead and sub them all in to my quadratic formula. Okay, so then I've filled in the negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 12, all divided by 2 times 3. Then I simplify. So negative 8 just makes it negative 8. And then when I put this all in my calculator, the way that it is, so parentheses 8 n parentheses squared minus 4 parentheses 3 n parentheses negative 12 n parentheses, notice that I'm not putting the square root in yet. I am just simplifying what's under the radical because this might be irrational. So it won't give me a nice number if I put it in my calculator. The only way to get what number is under the radical is to put all of this in your calculator and get the answer, which would be 208, but then I need to put that under the radical. And then 2 times 3 is 6. Now we need to simplify that radical 208. So off to the side I wrote radical 208, which when we find the perfect square that goes in, remember we find 208 on the list of VIPs, and then we start dividing by the numbers previous until we find the biggest perfect square that does divide in, and it's 16. The square root of 16 is 4, so this becomes 4 radical 13, which I can then put back into my quadratic formula on the left. So then I have this negative 8 plus or minus 4 radical 13, all divisible by 6. But we have to do pretzel method to simplify. So I'm going to divide the negative 8 by 6, and we do get a fraction, but that's okay. That becomes negative 4 divided by 3, and then when we do 4 divided by 6, we get 2/3. And remember that radical 13 is kind of treated like a variable, so it just comes along. It's 2/3 of radical 13. And then we still have the plus minus because this is technically two different answers. Negative 4/3 plus 2/3 of radical 13 and negative 4/3 minus 2/3 of radical 13. So it looks really messy, but that's why the quadratic formula becomes helpful for situations like this, where completing the square would have been really tough and dealt with a lot of fractions and we cannot factor. So just remember, when using the quadratic formula, you always need to first put it in standard form, identify the a, b, and c term, and then just substitute them in. When you substitute them in, always use parentheses around the variables that you are substituting in for, and be sure to simplify what's under the radical before you try to put the radical into your calculator, because it might be irrational, in which case you will have to simplify the radical as we did that with this example here. Okay, let's look at number 2 together. So we have f of x equals 5x squared minus 3x minus 2. We need to find the roots or zeros, so I need to replace the f of x with 0 equals. Then I'm in standard form, so I'm ready to go ahead and complete the quadratic formula to solve for the zeros. Now the first step is to identify what a, b, and c are, and then we can go ahead and write those down. And I like to just write those up above. So a is 5, b is negative 3, and c is negative 2. Then in place of the variables in our quadratic formula up here, we'll go ahead and put in the a, b, and c values using parentheses whenever we substitute in. So when we substitute everything in, we get the negative 3 plus minus, and then all of these under the radical with parentheses over 2 times 5 will now simplify. So negative 3 becomes positive 3. Everything under the radical, when we put it in without the radical, we get 49, so that goes under the radical. and then everything over 2 times 5 is 10. Now, I can take the square root of 49 because it's on the VIPS list, so this is going to become 7. So when I replace that radical 49 with the 7, I see 3 plus minus 7 over 10. Now, these are questions that I can actually go ahead and simplify. So we can either remember break it down here or break it to the side. It doesn't really matter. Wherever you end up with more space is fine, just showing that once we have this part, we're going to have two different answers, one with adding the 7 and one with subtracting the 7. So on the left, I end up with x equals 3 plus 7 divided by 10. So 3 plus 7 is 10. 10 divided by 10 is 1. So my first answer is x equals 1. And then on the right here, I have 3 minus 7, which is negative 4. Negative 4 divided by 10 is negative 2 over 5, negative 2/5. And those are my answers, 1 and negative 2 over 5. Okay, let's try another one. Okay, number 3, so we have the 5x squared minus 25 equals 0. So the first step, again, identify a, b, and c. So a equals 5, the number with x squared. B, since there is no coefficient with an x variable, that means there is no b value, or it's 0, 0 x's. And then c is negative 25. Now that I've identified those three pieces, we just need to copy that formula down, substituting in our a, b, and c values in place of those in the formula. Okay, so I sub in, so I have the negative out front and then a 0. Plus minus, all of the substituting in under the radical, and then the 2 times 5 in the denominator. So the first thing, negative with a 0, that's really just 0, because there is no negative 0. That simplifies under the radical to 500, and it's still under the radical, and then over 10. Now, the square root of 500, if I put that in my calculator, it doesn't come out, so that means that it's not a perfect square. So to remember that to simplify the radical, we need to find the biggest perfect square that goes in. So we start by finding where it falls on the VIPS list and then working backwards. So go ahead and give that a try. When we do that, I'll find that 100 is the biggest perfect square that goes in, so 100 times 5. The point of this is that I can take the square root of 100, it becomes 10, so then this can be simplified to 10 radical 5. So then when I look over here, now I'm going to go ahead and try pretzel method. So 0 divided by 10 is going to be 0, so I don't have to worry about that. And then when we look at this, we're going to do plus minus 10 radical 5 divided by 10. 10 divided by 10 is going to cancel, so I'm just going to have that radical 5. So my answer here is going to be plus minus radical 5. Okay, on to number 4. So here we have the 4x squared minus 5x minus 7. It's already all set to go. Everything is in standard form, so I can first go ahead and identify what A, B, and C are. Once we have those identified, then it's just a job for using the quadratic formula to go ahead and sub in A, B, and C in place of those variables in the formula. So when I sum all those things in, I end up with this negative and then negative 5 in parentheses, plus minus, square root, and then we have all of this underneath it, and then the 2 times 4. Now the next step is to do negative 5 to simplify that. That just becomes a positive 5. Then we have the plus minus. Now remember, when simplifying the radical, just what's under the square root goes in the calculator, not the square root yet. We leave that for last because if it's irrational, we don't want to end up having a long decimal and then I don't know what was supposed to be under the radical. So you always start by just putting everything under the radical without the radical or square root in the calculator. So we do that. We end up with 137, and then in the denominator, 2 times 4 gives me 8. So then my answer here is 5 plus minus the square root of 137 all over 8. Now, normally we would say, okay, well, let's simplify this radical 137. So if I went off to the side and I find 137 on the VIP list, then I go backwards, I won't find a perfect square that goes in. So that means that this can't be simplified any further. And then I could pretzel method, but when I do that, it's just going to make it look more complex because 5 divided by 8 doesn't come out nice, and then the 1 here divided by the 8 also won't come out nice. So I could leave it as this answer. But an equivalent answer would be to write it as the two fractions by using the pretzel method to divide both terms by 8. Okay, for number 5 here, we have w minus 5 being squared. That can be written out as a binomial times a binomial. So I could rewrite this as w minus 5 times w minus 5. Now, since I'm looking to find the zeros, I need to have a quadratic here, which is what was my red flag, that I can't just solve this because I won't have a way to take the square root and then take the square root of these variables over here. So I have to instead make it into a quadratic with a degree of 2, so I can then use the quadratic formula to solve for the solutions. Now, to multiply a binomial times a binomial, we're always going to use our area model so that we don't lose our middle term. So off to the side, I'm going to fill in my area model. Okay, so I have my area model off to the side showing w minus 5 times w minus 5. Now w times w gives me a w squared in this first box. W times the negative 5 here will give me negative 5w, and then in the next cell, negative 5 times w will also give me a negative 5w, and then in the last one we have negative 5 times negative 5, that gives me a positive 25. And then we go ahead and look for like terms. Usually they show up on the diagonals as they do here, so I have negative 5w minus 5w. That gives me negative 10w. So I can rewrite this side of the equation over on my quadratic as w squared and then minus the 10w plus 25. Now, although I have the degree of 2, I am not ready to solve yet because it's not in standard form. Before I can solve, I need to subtract the 3w and add the 5 so that it's equal to 0 instead of the 3w minus 5 being on the wrong side. Okay, now I have the w squared minus 13w plus 30 equals 0. I am now ready to identify the a, b, and c values and then substitute them into the quadratic formula. So I wrote down what a, b, and c are up here at the top, even though they belong with this. I just didn't want it to have too much writing in this area. So now I can use the quadratic formula to substitute those values in place of a, b, and c. So when I plugged everything in, I ended up with the negative 13 plus minus everything under the radical here, 2 times 1. So hopefully yours matches mine. Then we can go ahead and simplify. Remember, everything under the radical goes in the calculator, but you don't put the square root in until after we've simplified what's under the radical. Okay, now I have 13 plus minus square root of 49 divided by 2. Now the square root of 49, that is a perfect square, so I can go ahead and simplify that to be 7. Okay, so 13 plus 7, that's going to give me 20. 20 divided by 2 will then give me 10 for my first answer. And then on the other side, I have 13 minus 7. And remember, you can put these into your calculator to help you simplify. 13 minus 7 gives me 6, and then 6 divided by 2 gives me 3. So that's my second answer. And you can just box those as your answers. So x equals 10 and x equals 3. Okay, so number 6, we have 3x squared minus 2 equals 2x. So the first step, we need to get it into standard form, which means I need to subtract the 2x over to the other side. Now I'm ready to go ahead and identify a, b, and c. My a value is 3, b is negative 2, and c is also negative 2. So then we're ready to go ahead and substitute them into the quadratic formula. Once we have substituted everything into the formula, then we just simplify. So our negative 2 becomes 2. Root of 28 over 6. Now, square root of 28, I can go ahead and try to simplify that. So off to the side, I'm going to write that radical 28 down so I can find the perfect square that goes in. So we got to find 28 on the VIPS list. It falls between 25 and 36, and then dividing backwards till we find the biggest perfect square that goes in. The biggest one is 4, so we'll simplify this to 4 times 7, all under the radical. Then, because 4 is on the perfect square list, I can cross that out and it can break out of the radical to become 2 radical 7. And then that will go in place of the radical 28 in my answer so far. So this becomes 2 plus minus 2 radical 7 all divided by 6. Now since these are even numbers here, I know I can go ahead and simplify. When we divide the 2 by the 6, I end up with 1/3. Then I still have the plus minus, and then 2 radical 7 divided by 6 ends up giving me 1/3 radical 7. So that's my answer there. Okay, let's do another one together. Okay, for the next one, we have 5x squared minus 125 equals 0. So it's already set up so that it's in standard form, equal to 0. So I can just start by identifying a, b, and c. A is 5, b is 0 because there is no x, and c is negative 125. Then we just sum them all into the quadratic formula. So x equals 0 plus minus, we have the negative 0 up front with the substitution in everything getting parentheses. So this simplifies to then become 0 plus minus the square root of 2,500 all over 10. Now the square root of 2,500 does come out nice. It is 50. So then I have 0 plus minus 50 and then divided by 10. This breaks into two answers. So my first answer is 0 plus 50, which is 50, divided by 10 ends up giving me 5. And then on the other side here, I have 0 minus 50, so that's just going to give me a negative 50, and then divided by 10 is going to give me x equals negative 5. So those are my two answers, and you can just box them or together over here for the short answer before we go over some multiple choice. So f of x equals 2x squared minus x. So instead of f of x, we need to replace that with a 0 because we're finding the zeros are the roots. Then we're ready to go ahead and identify a, b, and c. A equals 2, b equals negative 1, and c equals 0. Then we can sub them into the formula. So we have x equals negative negative 1, and then the plus minus square root, all of those substitutions in with parentheses under the radical, 2 times 2. So go ahead and simplify. Negative negative 1 becomes 1. And then we have plus minus, under the radical becomes a 1, so radical 1 divided by 4. Now I can take the square root of 1, it comes out to be 1, so I can simplify this. 1 plus minus 1 over 4, which comes to two answers. 1 plus 1 is 2, 2 divided by 4 ends up being 0.5 or 1/2. Then 1 minus 1 is 0, 0 divided by 4 is 0. And those are my two answers, x equals 1/2 and x equals 0. Okay, so this next question, x squared equals negative 7x minus 5. Now, it asks which method would be best to solve for the equation. Well, if I look here and I look at my options, completing the square, the b value is positive. Well, first I would need to think, okay, well, what is the b value? If I look here, I know I would have to move this to the other side, but that would just make it a positive 7x. So it is positive, so that doesn't matter. Completing the square because the b value is even. Well, it's not even. It would actually be an odd number, so that doesn't seem best. X box factoring, since it can be factored. If I think about that, I would need to look at my a, b, and c, which would be 1, 7, and 5. So I would need two factors that multiply to be 5, but add up to 7. And the only factors of 5 are 1 and 5, and those won't add up to 6. So it can't be factored. So the quadratic formula would probably be our best because the others either can't be done like factoring or are a little more difficult because of having fractions. So to explain that, I just wrote out that a positive b value does not make it easier, and the b value is not even, therefore completing the square would require fractions. I cannot factor, so the quadratic formula would be best. Now for number 10, the solution of this equation, x plus 3 squared equals 7. Well, this is already on its way to being completed with completing the square, so I'm going to take the square root of each side. Then I would get x plus 3 equals plus minus radical 7. And then to get x by itself, I would subtract the 3 over to the other side. So I can see that my correct answer is choice number 3 here because the 3 would become a negative 3. Okay, so that's it for this video. Have a good night.